Random sampling is a statistical technique used in selecting people or items for research. There are many techniques that can be used. Each technique makes sure that each person or item considered for the research has an equal opportunity to be chosen as part of the group to be studied. Random sampling uses specific words for certain things. Population means every possible choice. Whether you're choosing numbers, things, or people, population means all the possible things I could choose. Sample, logically enough, means the thing or things you choose from the population to study. The following are commonly used random sampling methods. As you'd guess by the name, this is the most common approach to random sampling. Simple random sampling means simply put every member of the population into one big group and then choosing who or what to include at random. As long as every possible choice is equally likely, you will produce a simple random sample. An example of a simple random sample would be the names of 25 employees being chosen out of a hat from a company of 250 employees. In this case, the population is all 250 employees, and the sample is random because each employee has an equal chance of being chosen. Stratified random sampling is a method of sampling that involves the division of a population into smaller subgroups known as strata. In stratified random sampling or stratification, the strata are formed based on members' shared attributes or characteristics such as income or educational attainment. Stratified random sampling involves dividing the entire population into homogeneous groups called strata. Random samples are then selected from each stratum. For example, consider an academic researcher who would like to know the number of college students in 2007 who received a job offer within 3 months of graduation. He will soon find that there were almost 200,000 college graduates for the year. He might decide to just take a simple random sample of 50,000 graduates and run a survey. Better still, he could divide the population into strata and take a random sample from the strata. To do this, he would create population groups based on gender, age range, race, or socioeconomic status. A random sample from each stratum is taken in a number proportional to the stratum's size when compared to the population. Assuming we have a population with a total of 150 persons, 70 represents the health workers, 30 represents the educators, and 50 represents the policemen. If we only want the 10% of the population as our sample, then the number representing the strata must be proportioned to our population. 7 is for the health workers, 3 is for the educators, and 5 is for the policemen. This is now equal to 15 persons, which is the 10% of our population. This number of persons will be randomly picked from our strata to form our stratified random sample. In cluster sampling, instead of selecting all the subjects from the entire population right off, the researcher takes several steps in gathering his sample population. First, the researcher selects groups or clusters, and then from each cluster, the researcher selects the individual subjects by either simple random or systematic random sampling. The researcher can even opt to include the entire cluster and not just a subset from it. The most common cluster used in research is a geographical cluster. For example, a researcher wants to survey academic performance of high school students in Olongapo. He can divide the entire population of high school students into different clusters. It can be District 1, District 2,
District 3, and District 4. Then, the researcher selects a number of clusters depending on his research through simple or systematic random sampling. Then, from the selected clusters, the researcher can either include all the high school students as subjects, or he can select a number of subjects from each cluster through simple or systematic random sampling. The important thing to remember about this sampling technique is to give all the clusters equal chances of being selected. When studying statistics, you might come across many terms that if you aren't fully concentrated will create a lot of confusion. For example, take parameter and statistic. If you are talking about a parameter, you are talking about the whole population. A statistic describes only a sample of the population. Let us try to study these examples. 40% of 1,211 students at a particular elementary school got below a 3 on a standardized test. You know this because you have each and every student's test score. Is this a fact about the whole population? Yes, sometimes that's easy to figure out. With small populations, you usually have a parameter because the groups are small enough to measure. Let us have another example. 60% of the Philippine residents agree with the latest health care proposal. Is this obviously a fact about a very large population? If it is, you have a statistic. It's not possible to actually ask hundreds of millions of people whether they agree. Researchers have to just take samples and calculate the rest.